Right, I think we can get started as we wait for more people to trickle in. But hello, everyone. Welcome to our webinar today, bringing private LTE to electric utilities and co-ops. My name is Mary. I'm the marketing director at BLiNQ Networks, and I'm joined today by Dan Stuart from BLiNQ and Edgar Espinoza from PCS Technologies. A bit of background on your co-presenters. Dan is a senior sales engineer at BLiNQ. He has over 30 years experience in the wireless industry, supporting all types of wireless technologies, including Wi-Fi, microwave backhaul, and mesh networks. Dan has been working with LTE for the past 8 years and is an amateur radio operator. Edgar is the director of network engineering at PCS Technologies, and he has over 20 years experience in the technical side of the wireless telecom business. 18 of those years have been with PCS, and he has overseen solutions network design, systems engineering, and product support. I can tell you with confidence that Dan and Edgar have a wealth of knowledge to share with you today, which I hope will prompt some of your questions at the end of this presentation. I also want to mention that we are a UBBA member, so we're part of the Utilities Broadband Alliance. And through our membership, we have been able to access some important real-time resources and collaborate with utilities to gain insight into some of their pain points. So I know some of you here today are also UBBA members. I'd like to go quickly over what we will cover today. So Dan, if you don't mind switching to the next slide. So we'll briefly introduce BLiNQ and PCS for the benefit of those we have not had the pleasure of working with yet. We'll talk a bit about some of the problems we've recognized in the industry and our approach to those challenges. We'll then discuss how our solution comes into play with the Private LTE and CBRS. I know many of you expressed your interest in learning more about this topic, so I hope you gain some insights here. And then finally, we'd like to take you through a real-life case study where we teamed up with an electric co-op to bring fixed wireless access to rural Kansas. We'll then wrap up with key takeaways and some Q&A. But throughout the presentation, feel free to send through your questions via the Q&A or the chat box below in your controls. And then we'll take some time to answer as many as we can. For now, I'm going to pass it over to Dan, and he'll tell you a bit about BLiNQ and what we do. Over to you, Dan.
Thank you, Mary. Good morning to everyone. So if you don't know BLiNQ Networks, we're a leading LTE manufacturer of CBRS certified hardware. We're actually headquartered in Markham, Ontario, Canada. I actually work from my home office in Colorado Springs. My primary focus is in North America, but our reach is actually globally. Our products really address some of the major challenges in the deployment of rural broadband internet. We manufacture a really easy, all-integrated CBRS-ready network in a box. That's a lot of words there. That provides superior coverage in near and non-line of sight situations. We deliver high capacity and high throughput that LTE operators are demanding. This solution is actually very scalable, so it makes it a perfect fit for private LTE networks that we're going to be discussing in the following slides. We have a well-rounded portfolio of LTE products. We will be focusing on specific products used to support the case study, which we're going to be discussing later on. I'd encourage all of you to visit our websites that Mary's going to provide information for, or if you have detailed questions that you'd like to make, you can reach out to me directly, or Dan Lawrence or Terry Jones, which are our two sales folks in North America. So the next, oh, actually, this is for Edgar. Edgar, you want to go ahead?
Yeah, no problem, Dan. Thank you so much. Hello, everyone, and thank you for inviting me to this webinar. For those not familiar with PCS Technologies, we are a broadband wireless solutions provider and system integrator who's been serving various industries and communities across the United States, and we've been doing it for over 2 decades now. PCS Technologies is a leading provider of high-quality wired and wireless network equipment and services, including all aspects of network design and deployment, radio frequency planning and coordination, as well as full-cycle product support. PCS was established back in 1994 in St. Paul, Minnesota, where I am today. Through the years, we've gained extensive experience and expertise helping our customers build, operate, and maintain numerous wired and wireless solutions using only best-in-class technologies from diverse manufacturers, which have earned us to become trusted experts in the wireless, broadband, and private LTE industries for many customers across the country. Our approach to connectivity services is focused on customers' outcome and how the technology fits the need and not the other way around. At PCS, we like to establish close relationship with those vendors we represent, like the one with BLiNQ Technologies and their team of experts, such as Dan Stuart, who I know him for a few years now. And I've been collaborating and working together to deliver solutions that are, as the slide says, efficient, dependable, scalable, and successful. I've been with PCS for 18 years, and it is always my pleasure to collaborate with experts in this field and sharing our experience on this awesome industry. Thank you again for inviting me. Dan?
So we're going to be discussing why we're here and taking a look at the problems next. We'll get right into it. So public utilities have been building their own communication networks now for decades, primarily to enable those emergency responses and service restoration, especially in rural areas where the public LTE networks may not provide adequate coverage. Many of those technologies are actually still in use today, such as land mobile radio. Utilities and power industries across North America are constantly adjusting to new changes, like adopting IoT and upgrading their smart grid. Other organizations, utilities in the oil and the gas sectors are also turning to private LTE to support their advanced connectivity needs. The bottom line here is that private LTE is really a game changer. Private LTE systems that are owned and operated and maintained by energy utilities for their exclusive use can protect utility operations from malicious intent and mitigate those consequences of the unforeseen events that could potentially hamper their business when utilizing a public LTE. They provide utilities with increased reliability and control that can scale to their present and future needs. When we couple this with CBRS, utilities can combat faults in real time through remote monitoring and control, as well as supporting teams in the field with connected tablets and voice and video services. Both the mobile and fixed or static applications are taking advantage of the CBRS band as a medium for low latency connectivity to complement that existing fiber and microwave network links. This can help to serve this will help to serve supervisory control and data acquisition, commonly known as SCADA, system distribution automation, advanced metering, distributed energy resources. There's so many of these different applications that they have to be concerned about. It's a wonder, quite honestly, as I was doing my research, that utilities can actually manage through all of this. One of the things they do is they analyze and optimize their energy consumption. That's usually typically right on the forefront. So these new technologies have allowed co-ops to reach actually beyond their core business to utilize their existing infrastructure, providing member services with things like internet access and remote education. These new revenue opportunities and cost efficiencies are emerging. The COVID pandemic, as everybody knows, has made working at home and remote education a necessity for many families whose current internet service can't handle the capacity needed. Co-ops are actually stepping up to that challenge. So we're going to take a look at those challenges next. Sorry, just a second here. So utility providers are really under constant pressure to use their most reliable and secure networks possible. This actually becomes more complicated with the addition of these multiple and distributed energy sources like solar and wind energy. Monitoring and controlling these devices and guarding against potential hazardous faults, distribution automation, metering, video security, all of these are significant issues that the utility operator has to deal with every day. With the rise of these advanced analytics, intelligent automated devices, real-time control, devices with sensors and cloud connectivity are all experiencing growing demand. So customers, consumers, I should say, have become really accustomed to a higher level of service and responsiveness, which just adds more pressure on the utility provider. These are just some of the reasons why utilities companies are finding it necessary to decentralize their network and move to a wireless solution, which will enhance efficiencies and resolve challenges, along with lowering the cost. The need for spectrum is an ever-increasing demand. Broadband spectrum is truly fundamental in supporting LTE deployments. Well, any wireless deployments, I guess I should say. The FCC has begun a concerted effort to identify underutilized bands and modify rules to make them more inclusive. We're going to be taking a look at just one of those bands in a few minutes. Just for something that you may not have known, the federal government actually controls almost 60% of the spectrum. So, but now the FCC, through new regulations and legislation, the government is actually repurposing much of the spectrum for commercial use. As we move along, we'll be talking more about spectrum availability and also the benefits of using private LTE. This is just a short list to get you thinking. Functionality, reliability, scalability, security, and the most important that I believe is spectrum availability, which Edgar is going to talk about next.
All right, thank you, Dan. So let me bring some context to our discussion, and bear with me as we talk a little bit about spectrum. Why is it important? Why now? And why is a good timing for utilities to be looking into this? So outside of the telecom industry, spectrum is not typically a conversation you have with utility companies. Sure, utility companies have been operating their own wireless networks for years, like SCADA, land mobile networks, grid, MAI, AMR, etc. Typically in the low spectrum bands, but while these wireless systems are highly reliable, they generally use licensed spectrum that's allocated in narrow band channels. In addition to being limited in capacity, this spectrum is subject to congestion and interference from competing and often incompatible radio frequency operations on the same or adjacent channels. Because there's no spectrum dedicated for use by utilities for broadband applications with nationwide standards, different utilities operate their communication systems in different spectrum bands on proprietary technologies. So, as utility companies look to modernize their wireless networks to deploy new smart technologies for grid, improve capacity and coverage to support the sheer number of new devices, and bring new connectivity services to their customers in their utility territory, utility companies face big challenges which Dan just mentioned a little bit ago. So, without a spectrum, it is almost impossible to do planning as it impacts what kind of equipment you are going to be using, how much equipment you are going to need, what's going to be your cost of operation, and ultimately, what are the outcomes you are trying to drive. A spectrum is your starting point, and front and center of any discussion for a lot of industries when it comes about connectivity modernization. So, but what's different now, right? The difference is that utility companies now have options. So let me explain. So for long, there used to be only two kinds of a spectrum regimes you could use, licensed and unlicensed, right? And this is what we're seeing on this slide. Licensed spectrums gives you exclusive use, but at a very high cost. And even if money wasn't an issue, it's really not something you can just ask the FCC for. So besides, most broadband licensed bands are already owned and in use by tier 1 telecom carriers. So on the other hand, we have the other spectrum regime for unlicensed spectrum, which is free, but free for all means unlicensed spectrum is prone to interference. They're very strict and regulations with limited power levels, your range. It's open to multiple purposes for different technologies, etc., etc. So, but finally, and thanks to a rulemaking back in 2015, the available spectrum exclusive for broadband use and a third spectrum regime called share spectrum, right? What spectrum? This share spectrum is a it's a piece of a spectrum that is owned like the license bands, but is only lightly licensed, right? Welcome the Citizens Broadband Radio Service, or CBRS band. Sitting in the mid bands between 3550 to 3700 megahertz, was identified by the FCC as additional spectrum for shared wireless private broadband. This band finally enabled commercial enterprises like utilities with a path to improve coverage and capacity and finally converge their multiple wireless networks, right? Next slide, please, Dan. So let me talk a little bit more about specific about CBRS band. So share spectrum, we're talking about share spectrum. I mentioned it gives us the best of both licensed and unlicensed worlds, but how does this really work? So CBRS, I mentioned it's lightly licensed since it's either licensed or unlicensed depending on the user's tier. So let me break it down to you. So the first tier is for incumbents, right? This includes the US Navy radar systems who will always get first priority use that operate on the 3550 to 3700 megahertz band. To protect this space, there are a number of coastal exclusion zones that surround nearly all of the US coastline. This is to ensure naval vessels can still communicate with shipyards without interference. There are also protection zones located inland that protect the airways around fixed satellite space to air radars in the 3600 to 3650 megahertz band. This portion of the spectrum is protected against interference from lower tier users. The second tier user, it's for priority access licensees or PALs, right? PAL licensees are awarded to the highest bidder and allow coverage by a county basis. A single PAL license covers a 10 megahertz channel within the 3550 to 3650 megahertz band and are assigned in 10-year renewable blocks. PALs must accept interference from incumbent access users but provided protection from interference from lower tier users. Lastly, this lower tier user is the third tier, which is known for general authorized access, or GAA. These are unlicensed users who are last in line to use the spectrum across the 3550 to 3700 megahertz band. Well, this is a tier that is the most open. It has no expectation of protection from interference from any of the above tiers, either GAA or incumbent or other GAA users. So who's coordinating the spectrum access and guarding against interference? Devices that want to use the CBRS band first put in request to a cloud-based spectrum access system, or SAS, right, to reserve unused channels in a particular geographic area. If channels are free, SAS can grant the requests. When devices that have been granted permission to use channels are done with them, The channels are put back into the pool so that SAS can draw from them to grant further requests. The SAS database providers is the main control point for many CBRS networks. The SAS controls the grants, leases of a spectrum based on this three-tier process, acting as a dynamic policy controller, setting use priorities. The Spectrum Access Service, or SAS, is designed to reduce or eliminate interference between operators in this band. The SAS providers are private companies that are managing spectrum allocation in this band, which are Google, Federated Wireless, and CommScope. So now that we know how this works, why is CBRS so attractive now for utility companies? By having an open and easy access to a piece of a spectrum that you can call your own, and having access to major global ecosystem of 3GPP standard LTE devices, CBRS finally opens up a major opportunity to unlicensed users and enterprise organizations to establish their own private LTE networks, just like any mobile carrier, right? Notice on this slide how the CBRS band, also known as band 48, overlaps band 42 and band 43, which are global bands on an LTE, which means there is a equipment available already developed for these bands that with minor adjustments, it can also be used in the US for band 48 and CBRS. And that is a case for when now we see even mass production devices like iPhones and Android devices that have support for band 48, those can now also be utilized on this private LTE networks using CBRS band. So this is also thanks to a coalition of companies like Google, Qualcomm, Intel, Federated Wireless, and my co-host company, BLiNQ Networks, who have band together to form the OnGo Alliance to support CBRS implementers and adopters to develop, commercialized, and adopt LTE solutions for CBRS. The OnGo Alliance develops OnGo technology specifications and certifications to ensure interoperability of network components. And while there are already operators using the band, there is still plenty of spectrum available to new users, and the timing could not be better for the utility company. So in summary, CBRS enables enterprise organizations like utility companies to build their own private LTE networks, offering an express line of wireless connectivity to critical applications that require wider coverage, interference-free wireless spectrum, and guaranteed service level agreements for network performance metrics such as latency and throughput. It is now possible to deploy private LTE much more quickly and at a much lower cost than ever. With that, I'll let Dan take it from here to explain why BLiNQ Networks CBRS solutions have been the equipment of choice for multiple utility and other organizations leveraging the CBRS band. Dan?
Thank you, Edgar. So bear with me here. LTE stands for long-term evolution. That's the short. That's the short spiel. Private LTE really is simply a standards-based LTE, like you're utilizing with your phone. Only it's modified to fit the needs of a specific network type. The architecture can change based on the needs of the individual, but in general, this is kind of how it works. By the way, we teach a class that covers these topics in depth that can last for 48 hours. So this is truly as basic as I can make it based on the limited amount of time that we have together. So the eNode Bs in the upper left-hand corner, these are base stations. For you Wi-Fi folks that don't know about this, they're also referred in the CBRS world as CBSDs. Anyway, these eNode Bs are mounted typically on a tower or a monopole, and they connect with something called an EPC. This is called an evolved packet core. Again, for you Wi-Fi folks, think of it like a Wi-Fi concentrator. Okay. Users actually will connect to the eNode B. So this could be from their phone or a pad or or some other device. It could be a remote device for bringing in data, like a SCADA device. But it can also be CPE for customers that are looking for rural internet. So the EPC actually handles the messaging for signal and radio management of these eNode Bs, as well as providing the link connectivity from the UE to the network. The spectrum, as Edgar talked about, is used by each node connecting with the user equipment, and it's managed by that CBRS SAS that Edgar spoke about. The real beauty of this BLiNQ FW300i is the all-in-one base station. You can deploy an entire LTE network aside from the customer premise equipment in a single box. The products are fully FCC certified, 3GPP compliant, OnGo certified, and they're compatible with all the SaaS operators. And again, I want to emphasize this: we are fully standards based in all respects. As noted in the discussion about spectrum, private LTE networks use either the dedicated or the shared spectrum. This really puts the customer in control of the infrastructure and looking at their density based on their individual needs. With CBRS, interference issues aren't as common as they used to be, or they are in the unlicensed bands, such as 5 gigahertz. Also, with private LTE, you have a quality of service levels. This puts the customer in control of how the data traffic is prioritized from end to end, which allows the business and mission critical applications to continue to function even in situations where other networks are getting overloaded. The SIM is really the heart of the security for the wireless. It really ensures the devices have unique identifiers on the network and they're properly authenticated. This really gives the network administrators some real tight control over what devices are allowed on the network. And for those of you guys that are wondering, 5G is not replacing 4G. Really, 5G is building on 4G LTE, I should say, using updated radios and software. Right now, currently, if you have an early 5G phone that you're proud of and you're uploading videos to Google Photos, you might be surprised that you're actually using a 4G LTE connection for that uplink. Like anything else, 4G is going to become obsolete one day, but that day is really quite far out, and really for the foreseeable future, especially in the Internet of Things deployment, 4G is really going to be the mainstay. Since LTE with CBRS is standard-based, operators are not locked into a specific proprietary solutions. I can't overemphasize that enough. If you go with a non-standard based, you're really gambling that that company that you're with is going to be continuing to build and operate and manufacture the equipment that you need. Where being in a standards-based technology, you can switch generally from one vendor to another without a whole lot of with a lot of work, whereas otherwise it'd be a forklift upgrade. So we're going to talk now a little bit deeper about the FW300i, the internet working or inner working, I guess is what I should call it. Second, and take a quick drink of water here. How are we doing on time, Mary? Okay.
Yep, we're on track.
Okay, great. So this is a cutaway version of the FW300, and as you can see, it's a 3-sector design. So it's going to cover 180 degrees with the 60-degree integrated antennas. So there's 3 60-degree integrated antennas. These are all controlled through an RF switch. And it has 3 LTE radios and of course the internal GPS as well. So the FW300 meets all the IP67 requirements, which is about tough environments, where temperature variations from extreme cold and extreme heat, that sort of conditions. So you don't have to worry about that. Our design actually allows deployment of multiple FW300Is on towers, poles, and buildings or rooftops. So in a monopole situation, you can actually put these things back to back and have full 360-degree coverage with 6 sectors. Now, keep in mind that's quite a difference than the typical 3 or 4 sector design that our typical competition has. Each cell, it's designed to be an independent type CBSD. The FW300 solution utilizes industry standard time division duplexing, better known as TDD. It's an LTE radio, so we're running release 13. This really allows for robust wireless performance with extreme cost-effective deployments, customer premise equipment. The FW300i supports all the TDD frame configurations, but like the on-go standard, we're really focusing on types 1 and type 2. The FW300i supports carrier aggregation, which is really important to boost the capacity. We right now support 2CC. That's 2 common carriers. And in the future, near future, we're going to be supporting three common carriers. So the FW300 is really able to steer with variable capacity over different areas across that 180 of azimuth. This flexibility of the FW300i to support both large coverage models as well as capacity-driven models is a key cornerstone of our product. As you can see, these little circles down at the bottom, the one on the bottom left refers to this typical standard operation where you'd have one sector, you'd actually have 3 separate sectors and each one of them transmitting and covering 180 degrees. You can, through this RF switching, actually if let's say you don't have coverage requirements where that center circle that you see there, where that center circle is covering, you can actually move that radio and overlay it on the existing cell to provide a higher capacity overall. So you're literally putting an E node B, if you will, and overlaying it on top of the same antenna. Which is really unique in our fashion, and it really speaks to the flexibility that the product has. The output power, in case you're wondering, meets the FCC maximum of 47 dBm per 10 megahertz. So there's no worries there. I think that's probably the best I can give for this description. If you have questions, feel free to ask, and I'll try to help out with those.
Sorry, Dan, we did have a question in relation to FW300i, and you may have covered it in your points, but are there any specific advantages of FW300i versus other CBRS box options such as Cambium?
Well, our box, without a doubt, is unique in the industry. The ability to take that one box, with the Cambium product, you've got to attach external antennas, external GPS. With our box, you can actually even, not only is everything integrated there, but you can also load on the EPC. So this becomes as simple as bringing internet connectivity up to the Ethernet port on our box, and you're online. I don't know anybody that has that simple capability. If you think about this, this makes all kinds of sense for potential situations where a cell on wheels requirement for emergency for cities. It's just a no-brainer. You can literally deploy this thing within a half hour, 45 minutes at the most. So I think that's probably the real key differentiator.
Dan, Mary, if I may,
Yeah, of course.
just a pin to what Dan said. One of the big advantages that I see with this type of equipment and what we made recommendations about it is BLiNQ is a standard-based system, right? Versus Cambium solution for CBRS has always been a proprietary, right? So to me right now, one of the strong values that CBRS brings to the table, and it's precisely what I mentioned just a little bit earlier, that because you can leverage a whole ecosystem of devices already developed by a 3GPP global standard and complement the number of devices and systems that you can interoperate with it, and they will work. For example, bringing in different customer devices, handsets, CP devices for different types of applications to work, with BLiNQ. BLiNQ is not limited to only work with BLiNQ CP, but can also accept connections from, again, 3GPP, a standard CP that follows the LTE standard again. And again, that's not something that you can do with Cambium. And this day and age, I don't understand why would somebody would limit its to a single vendor, right? When again, there is already a whole ecosystem of devices that can interoperate if you just follow standard-based systems like BLiNQ and
That's
and
a really
others.
good point. It's a really good point, Edgar. Thank you. So, so next I want to talk real quickly about NetLink, which is the element management system. Keep in mind that we have a pretty good sized portfolio of different products. I'm really focusing just on the products that were utilized by the case study that Edgar is going to be talking about in a minute. So REMS, basically element management system. It's designed to be able to manage every BLiNQ device, including the customer premise equipment, as well as the eNodeBs and the EPC. NetLink REMS uses a container-based architecture, which means it can run on bare metal or in a virtualized environment. The components are really based on proven and scalable open source software. So what we're actually doing is using a Docker engine, for those of you guys that are Linux savvy, which means you can get patches or rolling updates with minimal to no downtime. We have a dynamic network discovery feature that allows immediately presentation, if you will, on NetLink as the eNodeB comes up. So you don't have to do anything about adding the equipment. It just adds to the network management system automatically. We use real-time data streaming. We use Elastic Spark, which provides that large-scale data processing. We also use Grafana. That's very common for real-time and historic dashboard data visualization, if you will. And we also allow you to adjust for customized filters. Basically, it's fast, flexible data management in real time. That's what it boils down to. It has the ability to correlate KPIs. So not only can you look at specific KPIs real time, you can actually look at them as they correlate together, which is very, very helpful in quickly evaluating the network health. So I think that's what I'm going to say on this. I don't know that I need to go any further. So we're going to discuss this specific case study. This is kind of the meat of our presentation today, and Edgar is going to take over here. So we're going to be talking basically about velocity internet. Edgar?
Yes, thank you, Dan. So I'd like to take you guys over a project we had the opportunity to be part of. And but let me just go over some details about the customer and the project here. So Velocity is an internet service provider based in El Dorado, Kansas. Velocity Internet is part of the Butler Electric Co-op, and Butler Electric formed Velocity Internet to bridge the digital divide experienced by rural America by creating cost-efficient and reliable ways to provide high-speed internet service to Butler's co-ops, members, and surrounding communities. So, so what was the challenge? As you all know, at the start of the COVID-19 pandemic, many communities, rural and metro alike, experienced huge spikes in demand for reliable broadband access to the internet. Overnight, things such as distance learning, telehealth, telework, emergency services, connected with friends and family, or simply purchasing goods online when stores closed were in extremely high demand. Rural communities that were already grappling with lagging internet speeds began this digital race at a disadvantage. With surging demand for connectivity, many rural providers couldn't meet their constituents' needs fast enough. One of the communities that Velocity serves is the Greenwood County in Kansas. The problem was that hilly terrain and low density population of the Greenwood County it presented several obstacles to obtain good quality connectivity, such as distance, coverage, and various difficulties due to terrain blockage. Velocity applied for the Connectivity Emergency Response Grant created by the state of Kansas under the CARES Act in September of 2020. It was awarded the funds to deploy a solution and to serve the eastern part of the Butler's electric territory. One of the conditions, however, of this grant was that the funds had to be used by January 2021, right? This is just from September 2020, and it needed to be done by January 2021. Velocity had to move quickly to select the best technology solution and team up with partners that would help them succeed on this challenge. So prior to utilizing CBRS, Velocity had already primarily using a 5 gigahertz unlicensed band for fixed wireless access. But this technology had limitations with the strict line of sight requirements, strict power output limitations, and some limited range, so on and so forth. It was obvious, the obvious course of action was to find a better technology that could meet those challenges. So us being a long-time integrator partner for Butler Electric from previous wireless broadband projects, Broadband reached out to us at PCS to help them select, evaluate, and build the most appropriate solution. And we immediately jumped to meet the challenge. Our proposed solution was to leverage the CBRS band, 150 megahertz of shared spectrum, and the CBS-ready hardware from BLiNQ, with whom we had already performed numerous very successful commercial deployments. Velocity evaluated the new CBRS band and felt it was an appropriate solution given CBRS current LTE and future 5G capabilities, and could offer good quality of service to customers across a greater distance when compared to their 5 gigahertz unlicensed previous deployment. The spectrum sharing scheme offered by CBRS meant ample bandwidth was as readily available with minimum cost. General authorized access, or GAA, use, which is the widely available, lightly licensed part of the CBRS band, would easily support the coverage area. So we recommended BLiNQ as an obvious choice for CBRS-ready hardware. Aside from the superior line of sight capabilities that we've witnessed from prior deployments, and the solution was highly scalable and at the right price point, ideal for Velocity. Velocity opted to use several BLiNQ FW300 base stations and CPEs, or customer premise equipment, to create the foundations of their new LTE network. The FW300, like Dan mentioned, is all-in-one integrated solution. Basically, internet in a box, is a low-cost, high-performance micro base station on a small package, small price, and easy to deploy, easy to learn, easy learning curve, and it also delivers the best cost per gigabit in the industry. So from prior projects with Velocity, we had a deep understanding of Velocity's pre-existing network. So we executed a plan to quickly build and integrate a new private LTE network, extending their existing network infrastructure. Over the course of 3 months, Velocity marketed the upcoming service, deployed the technology, and went live with their solution in record time. The first customer were connected on December 16th of 2020. So what were the key values delivered? As the slide shows there, when backed by an expert team, Velocity, PCS and BLiNQ in this case, Velocity launched a fixed wireless private LTE network under only 3 months. As of today, Velocity has doubled the size of initial deployment. Velocity also and Velocity CBRS network can achieve speeds of up to 100 megabits downlink and 10 megabits uplink for business and residents using BLiNQ. Velocity has also deployed CBRS into its existing 5 gigahertz network sites, complementing and improving the customer reach and capacity. So this is one of the customers, this is one of the projects that we were very proud to have teamed up with BLiNQ, and how it successful was during the deployment. So
Edgar,
yeah.
I just wanted to interrupt quickly. A quick time check. We're at 12 minutes to the hour, so we only have 1 or 2 slides left, and then we've got Q&A. So just FYI, we're at 2:48. Okay.
Very good, thank you. So well, let me just tell you quickly how we met the challenge. So we this is where our years of expertise and experience came together in order to put together a deployment strategy to deliver a successful high-performance network that met the challenge, right? And it was imperative that we, every time you have a challenge like this, that you start with a disciplined, well-organized steps to gather the requirements, survey and plan, come up with a design, installation, operation, and a full cycle support. And this is critical to understand what are those, what all that means, right? What is this discipline deployment strategy to us is key when you're working with a system integrator, right? It needs to be understood that when you gather requirements, what is the organization, what is the purpose, who and what who's going to be connected to it, what is the level of security, how many users, how much traffic, what's the wireless infrastructure that's already in place that you're going to be working with, anticipating growth, etc. For survey and planning, we were required to come up with site selection, which depends on knowing the locations of power and data sources, location and availability of data center, network elements, network management systems. And one of the things that made this, that was helpful, was that electrical co-ops and municipal utilities are ideally positioned to support broadband initiatives as their infrastructure requires for broadband uses nearly everything the electric infrastructure already does, including right-of-ways, security, environmental protections, power, and pretty much their logical design. This facilitated and expedited this phase. So as soon as some of these aspects were known, planning a network involved developing propagation analysis, coverage prediction maps, so we can start implementing the design. We showed Butler and Velocity, these propagation predictions using BLiNQ equipment in order to make sure that it was providing adequate coverage and capacity for the Greenwood County region, right? For their network design, we took into consideration network elements, core network services, customer premises, devices, integration with their existing network infrastructure, so on and so forth. Due to terrain and distance, a fiber deployment to interconnect tower sites was not feasible. As it had been on their prior network deployments. So we had to come up with a whole network of high capacity, high availability microwave backhaul network to bring in all the traffic to the nearest fiber connected node. As our point of entry for this new network expansion. That required careful engineering of transit sites, proper clearance, link capacity, and multiple aspects too. So one of the big portions to meet the challenge was once we had a plan and a network design that had been accepted, we also had to make sure that we execute on it, right? And how you build, right? And so during installation, luckily for us, we have a team with a wealth of knowledge and experience in construction for several industries, right? So working closely with Butler's field and construction crews, we team up to build communication towers, leveraging right-of-ways and power. And so for this purpose, we use strategies as in previous projects with Butler, which was the use of 120-foot monopole structures. These were direct burial poles where you drill the hole in the ground, put the base in, pack aggregate rock around it, and you can immediately stack the rest of the monopole sections. And you can have a whole communication sites in literally in hours. We installed rugged outdoor cabinets and network components that didn't require air conditioning to minimize maintenance, bringing power to the site, etc. So and this is on top of fighting weather and other aspects that as we were coming into October, November, and the winter season didn't make things any easier with some early snowfalls and so on and so forth. So so this was we were very proud of the job in collaboration with Butler's construction teams. Operation meant having to work closely with Velocity's network operations centers personnel, performing training on core and radio systems, making sure that SAS connectivity and acquisition of grants was there to begin transmission and operation, right? And so this is the importance of having the capacity and expertise to execute and support a network design all the way from core to the edge of the network. And we can move on to the next slide.
So yeah, we need to, we'll wrap up really quickly after this and we'll take in a couple of questions. So start sending in your questions now if you have any. Go ahead, Dan.
Yeah, so kind of the simple message that we want to get across is that you really want to make your partner, make sure your partner with a private LTE technology leader and a proven systems integrator with extensive experience and expertise. We got this in spades with PCS Technologies. These guys were awesome, and we would highly recommend them. Ultimately, when you're looking at deploying a private LTE network, the technology really has four main points. The first one being that LTE follows the standards, and I know Edgar spoke to that specifically several times. The second and third are the reliability and security that traditional proprietary hardware don't have. And of course, the last one is coverage. So BLiNQ solutions take the above and made an affordable, simplified, and easy to deploy solution for private LTE. We hope that we were able to be informative in this. And Edgar, I'm going to give you the last say so here.
Right. Thank you, Dan. So I just want to close with as I mentioned earlier, utilities already have been operating wireless networks, but their approach to their build-outs is fundamentally different from ways that traditional telecom companies do. So our best advice is for utilities is to partner with a system integrator that has already past experience deploying telecom solutions, right? That understands that application, that can develop a design around your environment and expectations, that can execute on that plan, and will support your operations for years to come, right? Hopefully, we can be that system integrator for you, and we will be very happy for the opportunity. And that's it.
Great, thank you, Edgar.
Okay, great. Thank you both. We have a couple of minutes left to take Q&A. So keep sending in your questions through the Q&A or the chat box, and we can address them right now. Just so you know, this webinar recording is available tomorrow, and you'll get an email tomorrow with a link to this so that you can share it. While we wait for some questions to come in, if they do come in, I just wanted to point you to some additional resources on the right-hand side. You can review BLiNQ's CBRS Ready Wireless portfolio if you follow that link. Also, these links will be available tomorrow. They'll be in the email along with the webinar link. You can contact us at info@. You can review PCS Technologies content. They have a really great repository of case studies and blogs. And also you can review the UBBA website. They also have some great resources there. So it doesn't look like we have any further questions. Dan or Edgar, is there anything you'd like to add before we close?
Well, just thank you for taking the time to listen to our webinar. And if you have any questions, feel free to reach out to us. I'm available at dan.stuart@blinknetworks.com.
Thank you.
Here. Thank you, everyone. And check us out at pcs-tech.com. Great.
Thank you, everyone. We really appreciate your time. I know we're at the top of the hour, so you can have, well, it's 3 o'clock now, so I'll let you go and have a great Wednesday. Thank you again for joining us, and we hope to connect next time.
Thank you.
Okay, thanks. Bye-bye.